So now what we're going to look at is we are going to look at limits as x approaches infinity. So far, some of our answers have been infinity, but we haven't looked at x approaching infinity. And so basically, it's what's happening to your y value or your function as x gets infinitely large or infinitely negative. So as the curve gets farther and farther to the right, or as the curve gets farther and farther to the left. So the terminology or the way that you write it is you just like that. So the limit of f of x as x approaches infinity, or the limit of f of x as x approaches negative infinity. So although we use this term, we realize that we can't actually approach infinity because infinity is not a number. It does not exist. Therefore, it's just a way of saying that we're talking about the curve as it gets infinitely far to the right or infinitely far to the left. One quick note that it makes no sense to talk about the limit of our function f of x as x approaches infinity from the right-hand side, and that's because we can't get any farther right than infinity. If we're going already infinitely far to the right, you can't approach infinity from the right-hand side, and you can't approach a negative infinity from the left-hand side. That's like saying go slightly like farther left than negative infinity, and we can't do that. So whatever you want to write for your paraphrase of what I just explained. You can write right there, but you can't be bigger than infinity and you can't be less than negative infinity. Okay. So there are really only four possibilities that would be answers for limits as x approaches infinity or negative infinity. So in the first example, your curve could just go up for forever. So in that case, the limit does not exist. So for convenience sake, we just say that your limit as your function of your function as x approaches infinity is infinity, and that example 9 is an example of that. So in this case, it says the limit of our function as x approaches negative infinity. So what it's saying is as we look at x values that go infinitely to the left, what's happening to your graph? Well, as I continue to look this way forever and ever and ever, my graph is going to keep going up for forever and ever and ever, right? So as I look this way, my graph would continue going up. So we would say our limit of our function as x approaches negative infinity, or as it goes to the left forever, would be positive infinity because my graph would go up. This answer here is always describing what's happening to your y values as your x values do something. The curve could go down for forever. So for example, in this scenario, they're saying, and if you look at example 10, they're saying as your graph goes to the right, and this is just from this example itself. So as I look forever to the right, what is my graph doing? So as I look this way, my graph is going down forever. So that's why the limit of our function as x approaches infinity is negative infinity. So as I look to the right, my graph goes down. Let's go ahead and answer this question about this example though. So the limit of my function as x approaches negative infinity. So as I look to the left forever, what does my graph seem to be doing? Oh, well, my graph goes up. So we would say that the limit as x approaches negative infinity is positive infinity. All right. The other thing that your graph could do would be to level off or become asymptotic is another way of saying that, to a line. So these are technically supposed to be dotted lines, asymptotes, as it were. So let's keep that in mind. And so if we look at, for example, the limit of my function as x goes to the right, as x approaches infinity. So as I look farther and farther this way, what y value does my graph seem to be approaching? Well, it looks like my y value seems to be approaching this asymptote, and this asymptote is at 1. So I would say that my limit as x approaches infinity is 1, because my graph seems to be climbing and getting closer and closer to that y value. As my function goes to negative infinity, so as I look in this direction on my graph, what does my graph seem to be approaching y value wise? So as I go this way, following my graph, it seems like it's approaching this asymptote, which is at -1. And then last but not least, we have to look at this graph, and this looks an awfully lot like it's oscillating. Remember we talked about oscillating in our last video, but an oscillating function is a function that when it oscillates, it doesn't seem to be increasing or decreasing at all. It just has the same kind of pattern over and over and over again, and that's not what this graph is doing, correct? So as this graph, as I look forever to the right, so as I look forever to the right on this graph, my graph goes down, comes up, goes down, comes up, but it seems to be getting smaller and smaller every time, so we would say it's leveling off, and it's leveling off to this y value that's right here, and we would say that y value is at 0. So I would say my limit of my function as x approaches infinity is 0, because my almost oscillating function, remember oscillating means it would have the same kind of height over and over and over again, this is leveling off to a particular y value, and that y value is 0. And then I follow my graph as x approaches negative infinity. So as I look forever this way on my function, what does my graph seem to be doing? Oh, well, it seems to be doing the same thing, right? My bumps are getting smaller on my graph, which means it's leveling off to this y value, and this y value is 0. So infinities can get a little tricky, but go ahead and use these notes that you have to go ahead and practice, and let me know if you have any questions.